All right, everybody. In this video, we're going to be focusing on lesson number 2 in Booklet 7. This lesson is on circumference. Now, for this lesson, you will need the note itself, the worksheet, and you might also want to be aware of this reference sheet in the back, all about circles. Now, this reference sheet talks both about the circumference and the area of the circle, but today we're just focusing on circumference. So let's start with what is circumference. In the previous video, we talked about the perimeter of various shapes, such as a triangle, a rectangle, or a square. The circumference is kind of like the perimeter, but only if it's the perimeter of a circle. Now make sure not to formally call it perimeter. When you're talking about a circle, you use the word circumference. But it still means the distance around the outside of the shape. We can see here in the diagram below that the circumference is this distance right here, all the way around the outside of the circle. Now, it is significantly more difficult to calculate the circumference or perimeter of a circle because it's not like we're adding up many different sides. There is only one different side to a circle. So instead, what we need to do is use an equation. And if you don't already have a calculator out, you 100% absolutely need a calculator for this lesson. So you are able to calculate the circumference if you have one of two things. Either the diameter, represented here by the letter D, or the radius, represented here by the letter R. The diameter represents the distance from one side of the circle straight through the middle to the other. If I jump forward to example 1, you can see here that the diameter is 25 inches. The distance from one side to the other. So in theory, I could find the circumference of that circle if I knew the equation, which I'll talk about in a second. You can also find the circumference of a circle if you're not given the diameter, but instead given the radius. Now, the diameter and the radius are very similar, but where the diameter gives you the distance from one side to the other, the radius only gives you the distance from the center to the outside of the circle. So we can see here in example 2 that I'm given the radius, which starts at the center, compared to example 1, where I'm given the diameter. Now, the relationship between the diameter and the radius is that the radius is going to be half of what the diameter is, right? So if I asked you up here in example A what the radius of this circle was, you can tell me that the radius is this distance right here, which is going to be 12.5 inches. Why do I know that it's 12.5 inches? Because I took 25 and I halved it. And the radius is half of the diameter. Similarly, if I look at this example down here where I give you the radius and I ask you for the diameter, you can find that because the diameter is the radius, but double it. We go all the way to the other side. You can see here it's twice as long. So the diameter would equal 62 feet here. How do I know that it's 62? I just took 31 and I doubled it. I multiplied it by 2 to get 62 feet. Now, you only need to know one of these, the diameter or the radius, in order to find the circumference. Depending on what you have, you're either going to use the top equation right here if you have the diameter, and the bottom equation right here if you have the circumference. So let's talk about each of them. The top equation takes this symbol right here, which we are going to call pi. Now, if you want to spell it, you spell pi P-I, no E. Now, pi isn't a variable. Pi will never change. Pi is always the exact same number. That number is 3.1415, etc., etc. It keeps going on forever. It never repeats those digits either. It's a different number every time. Now, I don't expect you to remember all of the digits of pi, so all that I'm asking you to do is remember 3 digits of pi. When you see that symbol, I need you to know that it means 3.14. So if you need to, I would take a second now, and at the top of your page, I would make a note that says pi equals 3.14. Put that somewhere where you're going to remember it if you need it. Okay. So if you have the diameter, you simply take that number and multiply it by 3.14. However, if you have the radius, then you're going to be using the second equation, the one that has the r in it for radius. If you're using the second equation, you're going to take the number 2, multiply that by pi, or 3.14, and then multiply that by the radius. Okay? So, now we are going to complete a few examples. Make sure that when you're following along with these examples and completing the homework, you're aware of which equation you should be using. Okay, let's get rid of all of this that I used for an example, and let's start from scratch. Bless me. Okay, let's take a look at example 1. Calculate the circumference of the following circles. Use 3.14 for pi and round your answer to the nearest hundredth. So, as I mentioned earlier, in this example, we are given the diameter. So I'm going to write d equals 25. Since we're given the diameter, I am going to use this equation up here. Let me rewrite that next to the circle. Circumference equals pi times the diameter. Or, in other words, circumference equals 3.14 times 25. Now, this is where you're going to need a calculator. Plug that in, 3.14 times 25, and you get an answer of 78.5 inches. So what that means is that this distance all around the circle is 78.5 inches. If I had a string and I wrapped it around, that is the length of string that I would need. Take a second, solve the next problem on your own, and then make sure that your answer matches mine. Now again, I'm going to write down that my diameter, the length from one side of the circle through the middle to the other, is 39 feet. I'm going to use that with my diameter equation, which tells me that the circumference is pi times the diameter is 3.14 times 39. Using a calculator, 3.14 times 39 is equal to 122.46, and here I remember my units, which is feet. Perfect. That's all that you need to do, and we're ready to move on. Now, this question did ask you to round to the nearest hundredth. Neither of these examples you need to round in because we never go past the hundredth, right? In our first example, I only go so far as the tenths. In my second example, I only go so far as the hundredths, so I don't need to round at all. You can keep up to 2 decimal places. Here in the second example, we're not given the diameter, instead we're given the radius. So I'm going to make a little note here that says r is equal to 31 feet. Now, since we're given the radius, we are going to use not the first equation with the letter d for diameter, but the second equation with the letter r for radius. And that equation, which I'm going to rewrite here, is circumference equals 2 times pi times the radius. Or if we would like to plug in our numbers, 2 times 3.14 times 31. Plug that into a calculator, 2 times 3.14 times 31, and we get an answer of 194.68, and we're talking about feet here. Again, they ask us to round to the nearest hundredth, but we don't need to because we only go as far as the hundredths. This last example, try on your own. Make sure that your answer matches mine. Our radius, which is equal to 24 meters here, is going to be used in the equation circumference equals 2 times pi times the radius, or plugging in the numbers, 2 times 3.14 times 24. Using a calculator, we get an answer of 150.72 meters. That's supposed to be an M for meters. Let me try that again. There we go. And that's it. Make sure you remember that pi is 3.14, and make sure that you remember which of the two equations to use, depending on if you're given the diameter, the full length of the circle, or the radius, which is half of that. Take some time to complete the homework, or rather the worksheet that comes afterwards, and as usual, let me know if you have any questions. Thank you.